Good morning, Dharmishtha madam, Dr. JDC Barad sir, Head of Department of Chemical Engineering, and good morning to everyone. Today we have with us Mr. Parth Shah, who will be giving his expertise on drying operation, which basically falls under the mass transfer operation. Mr. Parth has completed his bachelor's in 2013 from GSET College and master's in CAPD in 2017 from LD College of Engineering. He is having 1 year of industrial experience, and after successfully clearing GPSC exam in 2015, he joined Government Polytechnic as a lecturer and also completed his master's during the same period. Currently, he is pursuing doctoral degree with main focus on thermodynamic study of green solvent. So we heartily welcome you, Mr. Parth Shah, sir.
Thank
And
you.
now I would request Mr. Parth to start the session.
Okay. Thank you very much, Hitesh sir.
I also welcome Parth sir to the webinar series of RNG PIT, and your topic drying as a mass transfer operation is very much relevant, particularly to 6th semester students. And I am really hopeful that your session will be helpful to all of our students. Sir, please continue your session.
So, thank you very much, Head of the Department, Mr. Dr. Jaideep Barad sir, and Professor Hitesh Ramchandani sir. Thank you for welcoming me to sharing my knowledge to which your institute. So, I will start my session. So, basically, today's topic is drying. Drying as mass transfer operation. So, basically, drying, I am sharing my presentation with you. Okay, so now the PPT is shared. I have shared screen with you. So the drying. So drying is basically has number of application in most of wide range of application in industry for the chemical in number of like fertilizer, pesticides, pharmaceuticals, even number of dyes, pigments, industry. So drying is a very wide range of application as far as the chemical engineering aspects is concerned. Now, in today's presentation, I am going to have a number of topics I selected for my presentation. First, I will give you the introduction about the what is drying, then mechanism of drying, that how drying is work in mass transfer operation in molecule level. Then we will go for the drying equilibria. That is how equilibrium of drying is performed and the number of definitions related to drying. Then we will cover the drying rate curve, and then I will give explanation about some of the drying equipments. So basically we need to we have evaporation and drying. Both give the same amount of the nature of the working. Like in evaporation, we evaporate the moistures from the feed. Here it is important to note that feed mixture here in evaporation, here it is with liquid mixture with liquid mixture, that is we have concentrated the fluid mixture, that we evaporate one of the compound and we get the higher concentrated, like we have binary mixture of methanol and water. Now both are in liquid phase, we evaporate one of the component and we concentrate the other compound or our solution in terms of say water, like we have 50-50 mole percent ethanol and water. Now in evaporator we increase the heat transfer and we evaporate one of the components, say methanol, and we increase the water percentage from the remaining solution from 50% to 90%. So this is evaporation. In evaporation, our goal is to concentrate the solution. Again, I am repeating, we are very much interested in concentrating the solution. As compared to drying, what we are doing is we evaporate the moisture or the liquid present inside the solid material. Here the product I am highlighting with these are the product box that I have shown here. What happened is that air is come inside that box, and after the heat transfer takes place, the water is evaporation, and the water is get out with the air, and the remaining product that has less amount of moisture or liquid. So initial product has higher moisture content, final product has very low or completely dry moisture, completely dry solid. So this is dry. So evaporation and drying both are different. The basic difference that we are concentrating solution in evaporation, while in drying what we are doing is we are drying the product, the solid product, and removing the liquids. Here liquid is solvent or water, anything is there. Okay, so I have given little bit idea about the what is drying, how drying is done. Now I am giving you the points of the evaporation and drying. So first point, in evaporation, the removal of large amount of liquids. When I am saying methanol and water, 50-50 mole percent. So 50 mole percent methanol, if we want to remove, then we need to remove high amount of liquids. While in drying, what happens? We have very less amount of, say, 10% of liquid is available in solid, and we are removing that 10% to in traces like 0.1%, 0.01%. So that is comparatively less amount than the evaporation. Then second is the major difference is evaporation is at boiling point. If we want to evaporate methanol, we need to reach the temperature at 64 degrees Celsius. So what we are doing, we are operating our evaporator at 67 degrees Celsius or more than 64 degrees Celsius. So we will have complete evaporation of methanol. As compared to drying, it will not going to be that we will need to water evaporated from drying. So we need not reach 100 degrees Celsius in dryer. We are below our boiling point and drying is done. Third point is evaporation is done to concentrate the solution and drying is done to stable dry product. That I have clear mentioned in last slide as well. And the final point, in evaporation, water is removed as pure water vapor, or it might be mixed with other gases sometime. What happens that evaporation, the pure, here I have taken that water is evaporated as from the mixture of solution. So the water is removed and the pure water is coming out as a vapor. In drying, what happens that air is comes, and that air taken the liquid solvent, that is water with it, and our completely dry product is we get. Now the mechanism of drying. So drying, as I have consider that drying will remove the water or solvent with the help of air. So the basic governing principle of drying is that it is the transport of heat and mass. Here both things are happen in drying. First, heat transfer. The air is coming from the outside of the outside chamber. The air is contacted with our wet solid. Wet solid means that has high moisture content, right? I think wet solid is very familiar term with you. Okay, so wet solid, what happens that wet solid is comes in contacted with the air. This air is gives heat from hot air. That air gives heat to the liquid compound, and that liquid compound get heated. So this is heat transfer. Second thing, when the compound is heated, the air is taken some amount of moisture with it. So there is a mass transfer. So it is a transport of heat and mass. I have shown the diagram below where you can see that gas. Here when I say writing gas, I am considering that air is considered as a gas medium, right? So gas, what happens? Gas will come in contact with wet solid. That wet solid get heated with heat transfer, and then mass transfer with the moisture transfer from the wet solid to the gas. So our wet solid become dry and our mass transfer takes place. So this is heat and mass transfer. So the governing principle is transport of heat and mass. The second point I have written, the moisture can be removed within solid by variety of mechanism. When I say mechanism, see, if solid, we cannot say that there is only one type of solid. There is crystalline solid, like sugar crystals. There is granulars, that bigger size particle. There is powdery material. There are sheets, slabs. Everything is solid. Now that solid we need to dry. Then each solid has its own nature, and we need to treat that solid from that type of drying equipment. So drying is different for all this kind of solids. So I think the solid, depending on the type of solid, drying mechanism is very important to understand, right? So drying mechanism is clear that there is heat transfer and mass transfer. Okay. Now there are some of the very important terms that I need to clear, because these are very important terms for drying. First is the moisture content on wet basis. See here, wet basis I have written. It is very important, because when base is considered, then wet basis, then what wet basis includes. See, the definition is very clear. It is written in table as well. The moisture content means the quantity of moisture in the wet solid expressed in mass ratio. So the formula, mathematical formula is that moisture content in percentage is equal to x kilogram of moisture per 1 kilogram of solid plus x kilogram of moisture. When I have written 1 kilogram of solid, I have taken 1 kilogram as base dry solid. Again, I am repeating, 1 kilogram of dry solid. Dry solid means, let us consider that 500 gram of water moisture is present in 1 kilogram of solid. 1 kilogram of dry solid and 500 gram of moisture. So 0.5 kilogram is our x. 1 kilogram is our solid. So 0.5 divided by 1 plus 0.5. That is our moisture content on wet basis, right? So wet basis, it is a mass ratio basically. Moisture divided by total weight. Okay. Now another term is the moisture content on dry basis. See, one is the mass wet basis, another is the dry basis. In dry basis, what we are doing, we taking simple ratio of moisture to the solid. 0.5 kilogram divided by 1. For the percentage, I have multiplied by 100. So there is percentage, moisture content in percentage, right? So moisture content in wet basis and moisture content in dry basis. So two things are here. Two things we need to clear. That one, how moisture content we represents. When I am saying that solid has 50% moisture. So 50% on what basis? Wet basis or dry basis? We need to clearly understand that. Okay. So when I say wet basis, so it has 50% wet basis. I am again going to give you example of that, but the definition is very much clear right now. Okay. So I have taken one example to give you better understanding of wet basis and dry basis. Now I have taken an example that is very simple to understand, that the solid is dried from 80% to 5% moisture. So initially we have 80% moisture, 80%, and we need to reduce it to 5% only, right? So this is drying to removal of moisture. Now this percentage is wet basis, very important, wet basis. So we need to how compute the moisture to be evaporated, that how much kilogram of moisture to be evaporated per 1000 gram of dry product if we have. So now we need to convert that wet basis into kilogram. So the moisture content is 80%. If we have 80% of moisture on wet basis, that means that initial moisture content is 0.8 divided by 1 minus 0.8. That is the 1 minus 0.8, that is 0.2. So that 0.2 is the kilogram of dry solid, right? So dry solid. So moisture divided by dry solid. So that is 4 kilogram of moisture water available per 1 kilogram of dry solid. That is the initial moisture content. When we have final moisture content, so final moisture content is 5%. So again, final moisture percentage is 0.05 divided by 1 minus 0.05. So that is 0.0527 kilogram of water per kilogram of dry solid. So from 4 kg of water per kilogram of dry solid, we need to reduce to the 0.0527 kilogram of water per kilogram of dry solid. Now we need to get 1000 kilogram of dry product that has 5% moisture, right? So how much dry product has dry solid? So 1000 into 0.95. So that is 950 kilograms, right? 950 kilograms. This 950 kilograms solid is dry solid available in product. This dry solid is dye material. So initially also it will be 950 kilograms. Finally it will be 950 kilograms. 1 kilogram of solid, dry solid, has 4 kilogram of water initially, right? 1 kilogram of solid has 4 kilogram of water. From that we have reduced to 0.0527. So the moisture to be evaporated is 3750 kilogram if this is wet basis. Now I have completely again calculated that term, and the same numerical I have solved for dry basis. So if we have given the same amount, that 80% to 5% for dry basis, then how much water need to be evaporated? So initial moisture content now 80% is dry basis. So initial moisture content is 0.8 kilogram of water per 1 kilogram of dry solid, right? So initially, if wet basis we see there is 4 kilogram of water, now it is reduced to 0.8 kilogram. So entire numerical is changed on the basis of wet basis and dry basis, right? So 0.8 kilogram of water, we reduce it to 0.05 kilogram of water. So the amount of water we need to evaporate is 712.5 kilogram. So see, there is a large variation in the moisture to be evaporated. So we need to clearly understand the terms, that wet basis or dry basis. So I think there will be very much clarity about the how wet basis or dry basis are separated. Okay. Now we are going to further the drying equilibrium. When I have said that air is contacted with the wet solid, see air. So air is the atmospheric air, or we have some treated air. So that air is come in contacted with the wet solid. So the how much extent the drying will occur, that initially the amount of the moisture present in the solid, the first point, the moisture present in solid exert a pressure which is equal to or less than the vapor pressure of water at a particular temperature. What does that mean? The moisture present in solid has some amount of water. That water has its own vapor pressure. So that must be equal to or less than the vapor pressure of water at a given temperature. Say surrounding air is 25 degrees Celsius. So the solid water present inside the solid must have less vapor pressure compared to moisture present in the atmosphere. Then it will be equilibrium. So here solid and gas are in equilibrium. Solid means our wet solid, and gas is the inlet gas or air, our drying media. Okay, so that is in equilibrium. So moisture content in solid is equilibrium moisture content at operating condition. So when air is coming contacted with gas, it will have in equilibrium moisture then with solid at given condition. Up till there drying will occur, right? So see, equilibrium is the end point of mass transfer operation, any mass transfer operation. So we can reach up to equilibrium moisture content only, right? So this is the thing. Okay, now there is some more definitions, like this is the moisture curve. Those who are not familiar with the uh, number of definitions for drying, it is important to understand, because there are number of different phenomena of drying than other operations. Number one is the bound moisture. The bound moisture, that bound moisture means that if solid is mixed with liquid, then it will have a bounding force, and it has vapor pressure less than that of pure water. If you have seen the curve, the bound moisture he has shown up to when the graph is declining in left side, right? So that is the bound moisture. If I can show you here, up to here, it is bound moisture, right? What is bound moisture? The amount of moisture in solid that exerts a vapor pressure less than that of pure water at a given temperature. Okay, so what happens? The moisture that is inside the solid, right? If we have solid layer of say 2 each, so 2 each moisture, solid layer has the water available in at each and every instance, right? So we need to consider that how much moisture is inside the solid, that is bound moisture. Now that is not technical term, that solid moisture is inside the solid. So what we need to technically say, that moisture inside the solid exert vapor pressure less than that of pure water. If we have water available above solid, like we have solid surface and we have higher level of moisture, then what happens? That is unbound moisture. Its vapor pressure is equal to the surrounding temperature vapor pressure, right? So it is similar. So that is known as unbound moisture, right? So bound moisture and unbound moisture. Unbound moisture means the amount of moisture in wet solid in excess of bound moisture is unbound moisture. It exerts a vapor pressure equal to that of the water at given condition. Very important. Vapor pressure equal to that of the water at given condition, right? So what I am saying, that it is directly higher level, right? It has say water is available above solid, then it has similar vapor pressure that of the pure water at given temperature. So that is bound and unbound. Now there is equilibrium moisture. One more term given in graph. The moisture content in a solid that can remain in equilibrium with the drying media, right? When air is contacted with the water, the equilibrium moisture is this point where equilibrium is done and water is available inside the drying media. See, equilibrium, we cannot remove equilibrium moisture below equilibrium moisture content. We cannot remove that moisture. So X star, if you see x-axis graph, there is X star here. So this X star is our end point for the given temperature. If we change the temperature, we have another equilibrium concentration, and that is our end point. So X star is our equilibrium content, that up to which we can remove the moisture. So equilibrium moisture contained in a solid that can be removed with the equilibrium, that can be remain in equilibrium with the drying medium. The another term is the free moisture. Free moisture is the moisture in a wet solid in excess of the equilibrium moisture. This free moisture we can remove, right? So we can remove equilibrium free moisture, but we cannot remove equilibrium moisture content, right? So that is very clear. Okay, now this is the drying rate curve. For entire drying mass transfer operation, we all need to study this curve. Okay, now there is important thing, that the starting point of this is point A. This is our initial point, and this graph will move toward this side. Okay, So from point A, that is initial adjustment. From point A to we reach point B, then we have point B to C, then point C to D, and point D to E. When we reach point E, that is our X star, that is equilibrium moisture content, X star. Clear? So from point A, we reach to point E. So rate of drying, the y-axis, the rate of drying, the y-axis is the moisture removed in kilogram divided by time into weight of dry solid. Okay, so moisture removed, say we have 1 kilogram of solid, for 1 hour we remove 3 kilogram of moisture. So rate of drying is 3 kilogram per hour kilogram of dry solid, right? So that is rate of drying, and we need to plot that diagram, that rate of drying versus moisture content. This drying curve is known as drying rate curve. Drying rate curve is very important. See, there is rate, which means what speed drying is takes place, right? So we started from point A. Now point A to B. What happens at point A to B? Drying of solid accomplished by release of moisture. It is an initial starting point. Like the if heating is take place or equilibrium starting at a given temperature condition, right? We are supplying air at 50 degrees Celsius and wet solid is at 25 degrees Celsius. So from point A to B, there is change of the initial adjustment. Once point B is reached, then there will be constant rate drying. Constant rate drying means speed of drying is remain constant. So point B to C, we have constant rate drying. From point C to E, we have two different natures. One is straight line falling, then there is curvature line, right? So point C to D, that is falling rate drying. Point D to E, that is internal movement of moisture. We will going to look into detail of that. Like number one, the constant rate period. Here I am talking about point B to C, right? So the surface of solid remain uniform moist. Okay, you have one more diagram here, left side. Here the surface, this surface, right? So the surface of solid remain uniformly moist. Entire surface is completely moist, and hot air is come in contact with water, this hot air. So what happens, this hot air is come in contact with the surface and diffusion of solid takes place here. Diffusion, right? It's inside that chamber, and then there will be evaporation. So there is constant evaporation and rate of drying remain constant. There will be no change, right? So where at constant rate period, rate of drying is rate of evaporation is equal to rate of diffusion. Evaporation, rate of evaporation and rate of diffusion. Okay, so these two remain constant. Another point is the falling rate. Now falling rate has two different regimes. First is the unsaturated, point C to D, this curve. Now this curve, it is unsaturated surface drying. What happens first, in constant rate, the surface is completely moist, but now there is dry spots. There is spots on the drying surface. That dry spots is occurring, and this will reduce our for drying rate, right? So evaporation takes place. So hot air is comes in contact with this wet solid, and evaporation takes place. Here rate of evaporation is greater than the rate of diffusion, and there will be increase in the dry spots, right? So this dry spots is constantly increasing. When I'm saying increases means there will be, say, initially 0.5 centimeter, then there will be 1 centimeter dry spot, there will be 2 centimeter dry spots. So dry spots is increases. So this is first, this point C to D, where there will be straight line decreasing. Okay, then third is this curvature nature. The falling rate period, moisture content become very low, right? Now what happens, The dry spots also completely, upper layer of the surface is completely dry. Now internal diffusion. This internal diffusion, point number 2, internal diffusion of moisture is completely take control of the drying, and this will be, there will be no film present on the surface. So this will be internal movement of moisture, and we will reach point E, that is our equilibrium point. This will become the end of the drying. Here the rate becomes zero, completely zero, and there will be no further drying. So this is our equilibrium moisture content, right? So I think drying rate curve is very clear. I am again repeating very quickly. So point A, we have initial point. From point A to B, there is initial adjustment. Then from point B to C, there will be constant rate drying. After constant rate drying, point C to D, there will be unsaturated surface drying. That is the dry spots occurring on the surface of the wet solid. And after completely entire surface is dry, there will be internal moisture, that is point D to E. So this is drying rate curve. Okay. Now I am further going for the equipment side. So the drying operation can be done in batch or semi-batch manner. Say batch or semi-batch manner. We have know what is batch operation, what is continuous operation. Batch operation, we are unsteady state condition. Continuous operation, steady state condition. So unsteady state and steady state, we are familiar that in unsteady state the parameters are changing with respect to time, and under steady state condition it remains unchanged or constant. Okay. So the mode of heat energy supply, when I'm say air is contacted with the solid, then it is direct dryers. This direct dryers. Direct dryers. These are direct dryers. What happens in the direct dryers? That directly the air is contacted with the wet solid. In indirect dryer, there is the air is not contact directly with the solid, but with the through wall of dry. I will go into detail in next slide, like this. Now there is one equipment, that is tray dryer. It is very simple. Batch type operation is performed in tray dryer. See, these all are the trays. This is the trays of the tray dryer, in which we fill out our solids, wet solid, right? And we supply the air. Now this air is in contacted with the, comes in contacted with heater. So hot side temperature, right? The inlet air is at higher temperature. We heated that air so that we have higher temperature of air. So first we take principle that in tray dryer, hot air is continuously circulated, forced convection. Now I think you all are familiar with the convection, conduction, convection terms, right? So convection takes place to remove moisture from the solid placed inside the tray. Now you see, this is the air inlet. For each tray, air is come from left side and it will go out from right side, right? So when air is come from left side, enters from left side, it has very less amount of moisture available. But when air is taken out, it is in equilibrium condition. So it has higher amount of moisture, right? So we need to understand the construction. So it is very simple. Isolated walls are available in tray dryers, and the each tray is filled about 10 to 100 mm. Second point in construction, that is the 10 to 100 mm of the thickness of solid, wet solid available on the tray, and each tray has some distance of 40 mm so that the air can be passed through inside. Okay, now working. So how the trays work, as I have told you, that wet solid is already filled inside. The air is contacted with the wet solid, and equilibrium, mass transfer, heat and mass transfer both takes place. It is a direct operation, right? So heat and mass transfer both takes place, and then equilibrium air is taken out. So this will give us the drying of wet solid, right? So hot air is in turbulent flow, and turbulent flow of vapor pressure is in atmosphere and reduce the thickness of air boundary layer. As water evaporates from the surface, the water diffuses from interior of solid. This exhaust will taken out that wet air which that is coming out from the right hand side of the tray, and that will reduce the moisture content inside the chamber, right? So the air is not only single pass through, we again recirculate it with the help of fan mounted on the top. So about 90%, 80 to 90% air is recirculated, and 10 to 20% fresh air is introduced each time, right? So it is a continuously air is circulated inside the dryer, and we need to keep it over for 3 hours or 4 hours of drying. Okay. So what are the advantages? So first advantage is we can handling of material can be done without losses. There will be minimum losses or no losses in tray dryers. Second, it can be handled in batch or with a variety of materials or product that can be handled very effectively in batch tray dryers. The only disadvantage it is that it requires a more labors. Like we need to increase feed this tray, then we need to taken out that solids. So it is mount loading and unloading. Both we need to complete with the help of labors. So it is high labor work is required. And second is it is very time consuming process, right? So time consuming process is there. So for that, we need to consider that it is very lengthy process for the simple batch process, right? So it is very time consuming process. Okay. We can handle sticky materials that cannot be fluidized, or that cannot be simply where it is very sticky material that we can apply on the trays and we can dry that product. Then for plastic substance, precipitates, tablets, granular powders, etc., we can dry in this tray dryers. Okay, so this is very clear. Now I am going for one more dryer, that is spray dryer. Now the last one, that is spray dryer. Spray dryer is batch process. We can operate spray dryer in continuous or batch both. It is it is more of the continuous process, right? So what happens in spray dryer? See, word itself suggesting spray. So there is a spray of liquid or dyes from the top side of the dryer. The liquid is fall from the top, and we doing spraying of material from the top. Now spraying means we make small droplets of liquid feed, and these droplets are come in contact with this drying gas, right? So drying gas, what happens, it will come in contact with this liquid feed. Okay, so now I am reading out the principle. The fluid to be dried is atomized into fine droplets. Here one more terminology, that is atomizer. Atomizer, what happens? Atomizer means it will reduce the drops or liquid feed into small droplets, and that droplets come in contact with dry gas. So there will be very fast drying takes place, right? So it is very simple in construction. The atomizer comes in contact with dry gas, and then the bottom, it is conical in shape, so we can collect our dry solid, and then that is completely collected with the cyclone separator. So the drying gas can be collected from the exhaust, and our dry solid is collected at the bottom. So this is spray dryer, right? It is very highly effective. We can use for the dyes. We have number of dryers, spray dryers, that dye industry. Dye industry are using number of applications, has number of applications for spray dryers. So spray dryer is very important. So that is that the working I have already mentioned, that atomizer, then drying chamber, and recovery of dry products. This is the working. Now the advantage is it is very less time consuming. The liquid comes from the top from the bottom. It will reduce, it will dry the products. Like the liquid is liquid droplets comes from top to bottom, and gases come from top to bottom, and the drying takes place. So within few seconds we have dry product, right? The uniform size of the product. So for powdery material, it is very, very important. And we can get the sterile products. There is no contact of the outside atmosphere in the spray dryer. So we can use it. But we can, it is very expensive product, right? Second, high capital cost. The equipment costs are very, very high, right? So this kind of applications, this spray dryer is high capital cost requirement, and the thermal efficiency is low. The amount of energy that is comes from hot gas is very high as compared to we utilize for the drying. So thermal efficiency is very low for the spray dryer. So application, as I have told, these are the solid. You can take screenshot or something. That there are number of applications, that calcium sulfate dyes, starch, gelatin, serum, fruit juices, penicillins, vaccines, detergents. Number of applications where spray dryer is used. Okay. Now the third dryer, that is drum dryer. Drum dryer, it is a circulatory revolving drum. It is present and it is dipped. Now there are number of variations. It can be dipped, it cannot be dipped. So there are depending on the applications. I am slightly giving you deep solution, partially dipped. So I am reading out the principle. The heated hollow metal drum rotate on the longitudinal axis, which is partially dipped into the solution to be dried. Right. So this solution, if the drum is dipped inside the solution and it will rotate. Now what happens here? We supply our heating gas. So the wet solid is in outside region and the hot gas is in inside region, and we get the drying done, and we get our collected our dry product here, right? So this is the doctor's blade. We have given name doctor's blade, which separate this solid and collect in the screw conveyor belt. So this is continuously in one rotation. It drives most of the product. It is operated so 1 to 10 rpm, right? The conduction mode of the working very simple. Heat is transferred from conduction mode, and it will get evaporated the moisture from the outside surface. So this outside solid, wet solid, is dried and collected in the screw conveyor. Okay. The major advantage is we can operate heat sensitive material. It is very compact in size. The drum dryer is very compact. So we can use it in the industry where very less amount of space is required. Right. So that is one more. Second, rate of heat and mass transfer is very high. So we can utilize maximum heat. So it is thermal efficient product, and the product obtained is very dried from. Right. So that is the major advantages. The only disadvantage it is when solution is not very much soluble, like mixture slurry is very less amount of solid is present in non-soluble form, then we can use it. If very high amount of solid is available as non-soluble form, then we cannot use it, right? So that is the thing. There are a number of applications like milk products, starch, etc. Then there is fluidized bed dryer, then the FBD. So fluidized bed dryer, what happens? We are increasing the fluidized condition. So this increase in the fluidize. The fluidize means water, air is evaporated, or solid is evaporated. Solid is fluidized. Fluidized means it is in fluid state. Okay, so we are supplying this inlet air at very high velocity, and from the bottom, right? From the bottom, it will supply air, and the solid is fluidized condition, right? So that fluidized condition, the each particle gets dried. So that is fluidized bed dry. It is see the arrow here. It is back filter basically. So where we cannot have solid loss from the bags. Solid remain here and only air taken out, right? Only air, right? So the solid is inside. This is dry solid. Now dry solid is collected, and we have, after the operation is completed, we can get our dry. See, this is the air inlet condition, from where air is supplied from the bottom. It will go upside, it will fluidize solid, wet solid, and it is collected inside here, right? And air is taken out as exhaust, right? Exhaust, there will be, the liquid is taken out, and the remaining dry solid is collected over here. Okay, so this is basically fluidized bed dryer. We can name is FBD in number of operations. Okay, so construction is very clear. We have high rate of mass transfer in fluidized bed dryer compared to tray dryer. The first dryer I have explained, batch dryer, we have very less amount of time, and we can have more amount of solid to be considered, or we can treat in single pass, right? This is the last dryer I am going to discuss with you. Okay, freeze dryer. Freeze dryer is the latest technology, that is latest innovation in the drying operation. What happens? The triple point. Below triple point, we have sublimation. Sublimation means solid is directly converted into vapor. So freeze dryer are the latest technology where we decrease the temperature and pressure below triple point, and we convert that solid into vapors, right? So this is, it is a collected is a solid. Then see, first what happens, step one is the preparation and pre-treatment. What happens, we taken our solution, and we in normal vacuum tray drying, we fill our bottles of the solution in laboratory. Then pre-freezing, we decrease the temperature so that we get below triple point. Say for water, it is the triple point condition is 0.0048 degrees Celsius, and the particular pressure is less than 0.01 atmosphere pressure, right? So that is triple point condition. Where below triple point condition, what happens, that the solid water is converted into solid ice, right? That ice is dry now in sublime nature. So if we increase that dry heating, we give heating, then ice is converted into vapor directly. So this is sublimation, and this will convert it in completely freeze dry. In primary drying, we take the temperature of -10 to -30 degrees Celsius, and then we increase the further drying to 50 to 60 degrees Celsius, right? 50 to 60 degrees Celsius. This will give the complete drying of the ice or the water available in the mixture. So it is removal of moisture. How we remove moisture? We first convert into ice, and that ice is converted into vapors. So this is basically fundamental of freeze drying. Again, there is number of application we need to study in details, but I am going to give you a major overview of how freeze drying is done. We give vacuum condition so that we can get our freezing temperature. Okay, we can remove bacteria, antibiotics, blood, plasma, etc., where we can use freeze dry. Even there is increase in the number of freeze dryer applications. So that is we need to study the recent trend like in environment production, environment control. There is freeze dryer is now recent trend. Okay. So now I am going to summarize the today's presentation. So first we have studied what is how evaporation and drying are differs in terms of moisture present in the product and how product is changed. Then the mechanism of drying, how simultaneous heat and mass transfer is done. Heat and mass transfer both are done in drying. We have already covered that. Okay. Then we have studied number of terms like moisture content on wet basis, moisture content on dry basis, bound moisture, unbound moisture, equilibrium moisture content, and critical moisture. Now, then we have studied drying rate curve. Again, I am telling you, it is very important to study drying rate curve because it will give you exact idea how much equilibrium, how it will go to the equilibrium from initial condition. Okay, so this is very important. Then we have studied different equipment like tray dryer, spray dryer, and fluidized bed dryer and freeze dryer. Okay, so I think I have covered most of the topics. Uh, yeah. Now I will take any questions from your side. Um,
Okay, any question from the student side or our viewers? We can post in the live chat session. We will forward them to Parth sir.
yeah.
So, what question is that?
Yes, sir.
What is hysteresis in drying?
Yeah. Okay. So what happens that when moisture is absorbed in wet solid, like solid is capturing the moisture. So moisture is absorbing inside the material. So initially moisture content is increasing, but when we are doing drying, so there is absorption. There is increase in the moisture content, and then there will be decrease in the moisture content. So absorption, both phenomena occurs. Initially, there will be increase in the solid content, and this both are have different moisture content for at given temperature. So that that moisture variation is termed as stresses of the drying in drying. So,
Oh, that's fine. Thank you. Thank
Okay,
you.
now we
Uh,
have next question
there is
from.
also one question. What is funicular state and pendulous state?
sorry, sir.
Funicular state and pendulous state of solid material or moisture content. I think it is
Um,
related to falling rate curve, that linear or non-linear portion.
yeah, yeah. Uh, and that will actually I have not considered that in my presentation because the terminology will be increasing further in one lecture of the time. So I have read
I
this
think these two
presentation.
terminology are related to moisture content,
Yeah,
particularly in falling rate region. I think one is a
yeah,
linear one, another was a non-linear one.
yes, sir.
Okay. Okay, sir. Hitesh sir, any question from
Yeah,
live chat?
there is one question that which type of dryer is more suitable in chemical industry from second year student of chemical engineering department.
See, drying depends on the dryer. What type of drying material, or we can say what type of fluid we need to dry the wet solid. Like I have said that if there is if there is a powdery material or there is a sheet or slab, then there will be different types of dryer. Each industry has its own application, like in milk industry or in dye industry. Now we cannot compare that both industry because both output products are different. If industry and dye industry, so both has its own different set of applications. So we to see what is the actually input of wet solid, and that based on that wet solid we can take what dryer we can apply for the our drying operation.
Okay, thank you for answering that, Parth sir.
Yeah.
Uh, anyone have any question related to the topic? they can post in the live chat, or we could end the session here. Okay, so I guess you have solved most of the queries from our chemical engineering department community all over the Gujarat, I guess.
Okay, I
And
would like to thank Professor Jaideep Barad sir for giving me opportunity to share my knowledge, and Professor Hitesh Ramchandani sir and Pushpajit Barad sir also to giving me opportunity to share my views on this drawing with your institute, sir. Thank you very much, sir.
Thank you very much. Thank you.
uh,
Yeah,
thank you very much for presenting the nice session on drawing with all of our students all over the Gujarat. I guess they are watching this, and I guess you have covered the entire drawing topic from drawing chapter in just single session, and it was very nice session. So, on behalf of
thank you.
RNGPIT College and our Chemical Engineering Department, I thank you for joining us for this webinar, giving your time and cooperating with us. And
Thank you, sir.
in future, we will call you again for some more session based on the mass transfer operation.
Sure, sure.
Okay,
Thank you, sir.
now we will end the
Uh,
session.
my special thanks to Dr. Satish Shah and Professor Dilip Thakkar from LD and MSc University. Thank you, sir.
Thank you, sir.
Okay, so we will end this session now, and do join for our more session. Today we have next session at 1 p.m. So if everyone is interested, they can join our other webinar also. Okay, thank you.